A very good morning, students. So, this is the third session of chapter sound, and today we are going to see some terms related to a wave. So, our first term is the time period. So, the time taken for any particles to complete one vibration is called its time period of the wave. Okay, and it is denoted by the letter T. Now you can see that the particle which is completing a one vibration and the time which is taken by a particle to complete the vibration, that is called the time period, and it is denoted in this figure. Okay, shown as you can see it. So let's take an example of our daily life. Suppose there is a teacher which is being allotted with a period. So teacher has been given some time to complete his period. So suppose there's 45 minutes. So the time taken by a teacher to complete its period, that is called the time period. Now we can use that instead of time period. Here we can use vibration. So the time taken by a particle to complete its one vibration, that is called the time period. Clear? Now let's understand our second term, that is the amplitude. So what do you mean by the amplitude? The maximum displacement of any particle from its mean position is called amplitude of the wave. So let us understand this also with our daily example. Suppose this is a bob which is suspended with a string. Okay. Now there are three positions which is given of this bob. Now you apply some motion to this bob which is at the resting position, or we can say mean or center position. When this motion is being applied to a bob, that is the starting position, so it goes in a to and fro motion at B, which is the extreme position, then it comes back again to A, and then it goes to C. So here you can say that the maximum displacement of the bob, okay, either side from its mean position, that is called its amplitude, and it is measured in meter. Clear? So now our next term is frequency. Children, what do you mean by the frequency? Here you can see there are two kinds of frequency. First is the high frequency wave and second is the low frequency wave. So here you can see that there is less time which is taken by a wave, so vibration is more in high frequency. Okay, and here you can see in the low frequency diagram the time period is more, so the vibration, the wave which is forming is less, so that is of low frequency. Suppose a person speaking with a loud voice, so the time period is less in that, so it can reach to a distance. But if person is speaking in a low voice, so the sound does not travel fast and it cannot travel to a larger distance. Clear? So actually the frequency is the number of vibration produced by the source of sound wave in 1 second. Okay, here also the time period is less between the waves, so this high frequency, and in the second the time period is more, so there is a low frequency, and it is denoted by F or N. Okay, and the unit of frequency is hertz, which is denoted by the symbol Hz. Now we will see what is the wavelength. Here you can see that in the figure there is two peak point of the wave, or we can say this is the crust formation. So the distance between from one crust to the another crust, that is called the wavelength. Or by the simple definition we can understand that wavelength is the distance between two consecutive particles of the medium which are in the same phase. Okay, and also we can say that the length of a wave corresponding to one vibration is known as its wavelength, and it is denoted by the symbol lambda, and it is also measured in meter. So here you can see that there is a length of this medium which is given to you, or we can say that, or which differ in phase. Okay, so I hope you have understood the terms which are important to wave. Okay, so this is the end of this session. If you are having any doubt, then ask me. Thank you.